So in today's video, we're covering the circumference of a circle, and we'll work down to planetary speed. The first idea I want to talk about is these formulas that we have. Okay, we're kind of connecting these two ideas of distance, rate, time, and circumference of a circle with the idea of speed. Okay, so one thing we'll talk about is the circumference of a circle. You guys definitely want to memorize this formula. Another thing that I'm going to throw in there is that you might occasionally see someone write it as 2r pi, which is also fine. So it doesn't matter the order we multiply them in, but you should memorize that formula for sure. Okay? And then what I wanted everybody to write here on your page, if you please could, let's change the formula of average speed. What does the D stand for? Well, D stands for distance. And over here, okay, this is the distance that we travel in a given amount of time. And down here we have the time that elapsed while we were doing that travel. So this is how you get the average speed, okay? Because it can't tell us the speed at every point along the way, but it tells us the average speed because we know when they started, where they were going, and how long it took, okay? So this formula right here that I'm putting in the blue box, this formula actually comes from this formula, right? If I was to make this a little more simple, we could write distance as D, rate is R, and T is time. And if you guys start to understand that rates is basically a synonym with speed, right? The rate that I travel is called my speed, right? The rate I get paid at is called my wage though. So there's lots of different rates, and they all kind of go back to this equation that we're looking at here basically. So if we change that to be D equals speed times time, well, how could I solve this if I want to know what speed is, right? Well, if I divide both sides by t, then I'm actually done really quickly. You guys can see that we have the ability to cancel out these two t's right here because they're on top and bottom. So you can see that we get on the right-hand side the word speed, okay, the phrase, the number, and on this side we have d over t, and this is exactly what we got right here, okay? So these connections is made by algebra. I hope you guys can understand. So the next thing that we'll take a look at is the value of pi. It's kind of an important concept, so we're going to go slow at the beginning of this video because we're introducing ourselves to pi. There's a lot more to say about it, but let's start with the first idea, is that the value of pi is, it goes on forever. So I hesitate to even put a straight equal sign. We kind of want an approximate equal signs. We're never going to be able to actually write the full value of pi because it's infinite. Okay, so we got 926, 53, 58, and this actually continues. It goes on and on and on, so I'm going to continue that with a little dot, dot, dot notation, and we'll talk about what that means. Okay, those three dots have a special name, and that means that the pattern is going to repeat forever. Okay, some people call it the dotty notation. Somebody today I think called it the continuation, but what it's actually called is an ellipsis. So you guys might as well learn that. So again, the value of pi, it's infinite. It just goes on and on and on and on forever, and it never ends, so we can never actually finish writing it. So the second question is, what does pi represent about circles? What does it have to do with anything? Okay, so let's understand, if I take the circumference of any circle, okay, and this is something that people learn by measuring the world with ropes and stuff like that, trying to figure out how distance works. Okay, so the circumference of a circle, if I take that circle, that number, the circumference of the circle, the distance around it, so let's draw a little picture, right? If I take the distance around the circle, we call that the circumference. And if I divide that by the length across the circle, okay, that goes straight through the center, a straight line through the center, we call that the diameter. Okay, if I divide those, then guess what number we always get, no matter how big or small the circle is? We always get pi. So the diameter of that same circle, it'll always give us pi. So I'm going to erase this right now and just make sure you guys can put equals pi. Here's a little side note, the way that you write pi, you'll notice that we have this kind of style where they do little tail and it's flat, this one kind of curls out, and this one goes like that. I don't really do my pies like that. You guys can see that I kind of go like this, and I have a tendency to turn it like that. Every now and then, I might make it disconnected, okay? Some teachers even go like this. So you could be ready for all the different styles of pies, but there's basically all the same number. And if you ever, aren't sure what you're looking at, you guys are still learning, so just feel free to ask me. Let's jump into some actual problems now. So we're going to do this simple one right here. I'd like you guys to think about it. We did this in class, but if you were out, you should try to choose the correct answer. All right, and the answer is D, okay? It can't be C. Again, the idea that I told you guys earlier was that pi is infinite, right? So I'm going to need to cross out all of the ones that are not infinite. And we see there's only one that is infinite, right? And which one is it? The one that is infinite, let's get in here in presentation mode. The one that is infinite is D, okay? So we're just going to cross out all these other ones. 3 is not infinite. 3.14 is not infinite. 3.159 is not infinite, okay? But this is infinite, so it's the only one that we could go. It just keeps going on forever, okay? So the closest one that we could pick is D, and even that is not infinite really, right? Because we had to stop and do something here. So the next thing we're going to talk about is how do we actually do a problem. Okay, we're going to look into number 4. So we'll be looking at this just basically doing multiple choice problems, but I am going to kind of ask you guys to follow along and do your work, okay? But in these first problems in class, I think a lot of you guys were using a calculator, even though it was only multiplying by 2, and you just have to be ready to do this in actual class without a calculator at some point. So let's begin. Okay, the circumference of any circle is 2 pi r. So now we go plug in the value, okay? 2 and pi are the same, but the r is different, and again, the radius of a circle is what I get when I take the distance from the center to the edge. That's called the radius. Okay, so right here I put 7. We get 2 pi times 7, and that's 14 pi. So we have that, and don't forget that this is in feet. So what I'd like you guys to do, I have my students say this, I want you to write the exact value. Okay, and a lot of times people think that that means that we have to get a decimal, okay? But the decimal of an infinite number is an approximation. So this is the exact value right here, okay? We're done. When we leave it as pi, that's as exact as we can get, okay? Because anything else would mean I'd have to stop writing the digits, and then it's just an estimate, right? So this is complete, and if you guys see that we have to do B, and this is the answer, okay? And basically, we're just going to have to double whatever our radius is, and we're going to put that in front of pi. So since 2 times 7 is 14, we just put that next to pi, and basically we're ready for the next one. Okay, so now let's get to number 5. Hopefully you can try this on your own. Okay, so we're going to write the formula. C equals 2 pi times the radius, and the radius in this case is 3. So 2 pi times 3 gives me 6 pi, and this is miles. Okay. Again, this is the exact value. So we'll go ahead and move on to the next one. Let's get number 6. I think we're at a point where now you guys could probably try this on your own. Okay, we should be able to double 9 and know that that's 18, and then we're going to put pi next to it, so we should get 18 pi. Let's try the next one. Okay, for 7, so go ahead and make your choice. Okay, what do we do with the radius? Okay, we double it. We multiply the radius by 2. So 6 times 2 is 12. And 12 pi is 12 pi. So we leave this exactly as 12 pi. Okay, so that's good. So now we'll move to this one. So now we have the same idea. And on this one, I still would like you guys to write the exact answer as we did before. So for number 8, it's the same idea. We're just going to write 2 pi r. The only difference, again, is on this problem, we don't have the multiple choice. Okay? So we'll put the 5 inside of it, right? 5 times 2 is 10. And we'll leave the pi right there. And that's in meters. Okay, so these problems don't take forever, and again, that's the exact value. So I think we can do one more. Okay, so see what you get for the answer on this one. And I hope you know it's 22 pi, and I hope you can do that in your head, right? So we get to the next one. We have another one with 10. Okay, so go ahead and try to do that in your head. Got 20 pi. Okay, so now we're going to this one right here, 11. Okay, try to do this one in your head, perhaps. Maybe you could write it down. We should be able to show our work, but that doesn't mean that you shouldn't be able to do it in your head before, and then check to see if it is what you thought it would be. Okay, so for this one we should get 6 pi kilometers. Okay, so now we actually have something that's a little bit more complicated. Notice this, use your calculator's value of pi and round your answer to the nearest tenth. So let's begin doing that by just working through the basics. Okay, the first thing is just to do the work as we usually do. So we're going to write everything, and then we'll jump to the calculator when it's the right moment. Let's write C equals 2 pi r. Okay, we already did this problem just a second ago, right? So we know 2 times 10 is 20. So we got 20 pi meters. Okay, well, that's not good enough. Okay, again, this is exact form, but we want to round our answer to the nearest 10. So this means we have to get an approximate value. Okay, so let's label these again. This is the exact value. Okay, we don't want that. We want the approximate value. Okay, in the real world, you can't make things perfectly. You can make things just perfect enough, right? So we have to try to make things to a certain level of tolerance, all right? So we're going to go take a look right now and try to figure out, we're rounding to the nearest tenth, so that means we'll have to look at what we have in the hundredth column. Let's go ahead and jump over to Google. I think this is probably going to overload the board. I think it's a little distracting, so I'll just go ahead and get rid of all that. And let's go plug in the value that we had. Again, you would recall that we're doing 20 times pi, right? So notice I have pi right here already in the calculator, okay? And if you're lost, I'll clear it all out. We're going to do 20 times pi. Okay, and like I said earlier, you can notice how this pi looks a little different than that one, but there's still pi, okay? So you kind of have to know how to read it. And now we get 62.83. You see that? So 62.83 is going to be the value that would go here below the calculation that we were just making. Okay, so we have 62.83 meters. And now we need to do the approximately equal sign, so that's where it's wavy. And then we have 62.8. Okay, to figure out if we're going to the nearest tenth, we have to learn these places, and I hope you know them already. This is called the tenth, and this is called the hundredth place. Okay, so to round to the nearest tenth, we look at the digit in the hundredth place, and if this is a 5 or bigger, then we round that number up. Okay, but this is 3, and that's smaller than 5, so we keep this as an 8. Okay, so the idea is really like, is this closer to 62.80, or is it closer to 62.90? That's really all we're doing when we're rounding to the nearest tenth, okay? And it's closer to 62.8. So just don't forget to put meters right there. Okay, so we'll continue now. Okay, for 13, we know we're going to get 12, right? And so if I do 2 times 12, I get 24. And so the circumference of this will be 24 pi. So to get that, I'll go to my calculator and do 24 times pi. And if I hit equals, we have this value, 75.39. Okay, 75.39. So let's go make sure that we get that written on the slide. And we're getting done with this. We're almost done with this little section to move on to the planetary speed really quick. Okay, so doing that in the calculator, okay, don't forget the exact value. Well, now we have to get an approximate value. And I guess I could really put one more straight equal sign here is fine. Okay, we can call that 75.39 miles. And then think about it, right? We're trying to round to the nearest 10. So this is a 9, so that means the 3 is going to go up to a 4. Okay, but don't forget to put the approximately equal sign. and we have 75.4 miles. All right? So there we have that one. We can continue a little farther down the list. I have to leave a couple of them without any assignment, without any answers, I think, to leave you guys to know that you didn't just copy all of them. Okay, but I'll do 14 and 15 before you guys get done. I'll leave 16 and 17 as an exercise for you. Okay, so the answer for 14 should give you 25.1. So work through the problem and make sure you get that. You should try 15 also. Okay, go ahead. Why don't you pause the video and check your understanding and see if you get the right one. Okay? So please go ahead and make sure you've done the work because I'm going to reveal the answer right now. 3, 2, 1. You got 63.5. Okay. So now, I told you guys 16 and 17. I'll leave those alone. You guys can do that at home. And now we want to go over and do one of the speed of a planet, the rotation problems. Okay, and after this, I'll probably be able to call the video wrapped up. So what we're going to do here is recall the idea. Like it says, draw a diagram to illustrate the planet. Okay, so the planet of Saturn, we're going to draw right here. Okay? And the radius of Saturn is 36,184 miles. So we have that right there. I guess I could have made my circle a little bigger, but the idea is there. We have our circle, okay? And so what I want to do is I want to figure out the circumference of the planet. I want to figure out how far it is around Saturn. Because if it turns around every 10.7 hours, and I know how much that is, then that can give me its speed, right? Because I know how far it turns, and I know how long it takes it to do that. It takes Saturn 10.7 hours, okay? And don't forget, a day is when a planet spins around one total spin. So we begin by just stating the first thing that we want. We want to find speed. So let's think about how to actually get that. Well, this formula that we have is that speed, okay, is equal to make matters a little more simple, right? Distance over time. Okay, so we need to find the distance. Now we know the time, don't we? Right? The time is 10.7 hours, and we measure speed in miles per hour. So we always want the hours on bottom if we're doing a speed problem. And then on top, we want to have the distance, and that is going to be, right, the distance is equal to the distance around a circle, right? And since the planet is a circle, we can use the formula for a circle. And this is a really big idea that I promise you I will put on our first test. I need you guys to understand the reason why we can use this circular formula even though Saturn is a planet. Okay? So let's go plug in the values. Our radius is 36,184. So we're going to work through this value right here. If you do this in your calculator, you should be able to get 2 times pi times 36184. And you should have the value of 227,350.77. And that'll be enough, okay? Because we'll round to the nearest tenth like we did in the other problems, okay? And this is in miles, right? Again, it's the distance around the planet Saturn, okay? So every time that Saturn does a full spin, this is how far it spins. So we need to take that number and we need to divide it by that value of 10.7, and we would be complete with this whole problem. Okay, so we're going to do that calculation right now. I'm dividing by 10.7, and I get my speed. I'll write my final answer down here. Okay, and the speed is going to be 21,247. Okay, and it says 0.73, and this is miles per hour. All right, I can't help but make sure that we round correctly. So the very last thing we're going to do is write 0.7 and pH, right? That's a 3, so the 7 doesn't have to round up. Okay, there you go. We have done an example of how to get the speed of a planet. Okay, you guys should use this to help you get through the other problems. You could look through your notes because we've done those before. So now I'm just kind of giving you guys a place to make sure that you can work through all these steps and we can figure out what's going wrong, okay? Maybe what's going wrong is you're forgetting to divide, or maybe you're just not doing the circumference correctly and you're thinking that something else is going on. So there might be a misunderstanding, and this is why it's important to communicate with your teacher. So just let me know if there's something that I can clear up for you. But we'll go ahead and call this video done. I hope this can help you guys out. I'll post this right now, and don't forget this assignment is due on Friday at the beginning of class, all right? Good luck, everybody.